Hi, welcome back to Maths Learning Groups. Now today we are going to look at Tong School 2020 paper 1. So we are going to look at the concepts. Alright, we're going to revise the concepts on what your child has learned in P5, P6 and even P4. So when we go through the paper 1 lesson, it's important that you have done. Okay, you have done the paper 1 already before you watch the video, so that you can know your mistakes and understand what happened, right, in your steps. So again, there are also shortcuts in paper 1. So the reason why we need to be aware of the shortcuts so that we can complete the paper 1 in time and also have enough time to check our answers. Alright, so let's go straight into the paper 1 and then let's see whether how well you have done for paper 1. Okay, so which of the following numbers is not 250,000 when rounded to the nearest thousand? So what I will do usually in my solving, I will highlight the keywords. Like for example, there's a word not. Okay, a word not. So I will take note of this word. It's not 250,000 when rounded to the nearest thousand. Okay, so to round numbers to nearest thousand, what I will do is there are 3 zeros in 1,000, and I will draw a line to show the last 3 digits. And then I look at the digit nearest the line. Is it 5 and bigger? If it is, then I will add 1 on the next digit and I will get 250,000, which is not what I want. So I will cross it. Alright, next one. Same thing, draw a line to show the last 3 digits. And is it 5 and bigger? Yes, so I will add 1 on the next digit and I will get 250,000. So again, it's not what I want. Okay, 250,495. Do the same thing. Draw a line. Show the digit that's nearest the line. Look at the digit nearest the line. And is it 5 and bigger? No. So you don't add 1. So you will still get 250,000, which is not what I want. Okay, and the last number, you draw a line and you look at the digit nearest the line, right? And is it 5 and bigger? Yes. So you add 1 on the next digit and you will get 251,000, which is not 250,000. So the answer is number 4. So this is how you round off numbers to nearest tens, nearest hundreds and thousands by drawing a line, okay, to show how many digits there are. So if there are nearest thousand or nearest hundreds, then you draw a line to show the last 2 digits. If it's nearest tens, then you draw a line to show the last 1 digit. And you look at the digit nearest the line, and then you ask the question, is it 5 and bigger? If it's 5 and bigger, then you add 1. If it's not, then you just leave it alone. Okay, number 2. Now, number 2 is decimal. So this is your P4. You're being tested on your P4 topic on decimal. You will need to know the place value. So 813.256. So what's the place value? Now, the digit in front of the decimal point is a whole number. It's actually a whole number. We call it the ones place. And then after that will be tens. And then you have the hundreds. So these are your whole numbers, alright, which is what you have learned in P1, P2, P3. But when you come to P4, there's decimal, right? There's a decimal point. So behind the decimal point, that is your tenth. So when you see a TH, immediately you must understand that you're looking at decimals already. And then your digit 5 will be the hundred. Okay, so there's a TH. And then the digit 6 that is getting further away from the decimal point will be the thousand. Alright, so these are the different place values that you will need to know. So which digit is in the hundredth place? And that will be digit 5. So answer number 4. Okay? Alright, question number 3, express 1.5% as a decimal. So for this question, there is a shortcut here. Alright, and usually students, they have difficulty doing this because they just don't know how to convert to decimal. So how do we change it into a decimal? It's actually very simple. Whenever you see fraction, or when you see percentage, you think about fractions, right? Can I convert to fractions? And then from the fraction, you convert to decimal. So percentage to fraction is something over 100. Whatever percent that you're given, is always out of 100. So the percent is over 100. And then what does this fraction tells you? It tells you that dividing. Like for example, 1.5 over 100 is also 1.5 divided by 100. And then what do you know about decimals? You need to divide. You need to shift the decimal point to the left. So you shift the decimal point to the left because it's dividing 2 times. And why 2 times? Because there are 2 zeros. Okay, there are 2 zeros. So you will have to shift the decimal point 2 times to the left. So like this, alright. So you put your pencil near the decimal point and you shift 1 and 2. And then you see there's an empty basket there. You put the 0 inside. And there's an arrowhead. So you put the decimal point on top. And there's a 0 in front of the decimal point. So what is your decimal now after you divide? Your decimal now is 0.015. So answer will be number 3. So there's a lot of things to learn over here. To change percentage to decimal, you have a fraction as the middle person, as a bridge. And then use the fraction to do your dividing. All right, shift the decimal point, and then get your decimal. Okay, number 4. Find the value of 4a plus 12. Right, 4a plus 12 over 4. Okay, so there's something about this problem that I would like to raise up. Like students, they like to break up the steps, like 4 times 8, 32, and then 32 plus 12, you get 44, and then 44 divided by 4, and you get the answer 11, which is correct, nothing wrong. But the danger about doing this way is you may forget, or you may forget to do the last step, or you may lose track of what is the next step. So don't break up the steps. So the best way and the fastest way, the most effective way, is to put everything together in one step. Like for example, what is 4 times 8? So you can just put 4 times 8 is 32, and then plus 12 divided by 4. So put everything together as one step so that you see everything as a whole. Right? You see everything in one clear picture. Alright, then from this way of doing, you understand that you will need to add first. So 32 plus 12 will be 44, and then over 4. And then you will know that you need to divide by 4 because it's written clearly, so you will not lose track of what you are supposed to do next, right? If you break up into different steps, break up your steps, a few things will happen. You will forget to do the last step, or you will forget, or you will be lost. Okay, you'll be lost on what is the next step to do, right? But if you put everything together, it will guide you to do the next step one at a time. Okay, the next one, what is the value? So this is testing you on dividing fractions. So 1/3 divide by 3 over 7. So your teacher will have taught you keep the first fraction, change the divide to times, and flip the second number upside down. And it can be cancel to make the number smaller. We can't. So if we can't, then we multiply the numerators. So we take 1 times 7, and then 3 times 3. So that's how you multiply fractions. You multiply the numerators, and then you multiply the denominators, and that's how you get your answer, 7 over 9, which is answer number 2. Alright, question number 6. Okay, so question number 6, which one of the following is most likely the height of a classroom? Height of a classroom in the height of a cupboard in the classroom. So which is the most likely height of a cupboard in the classroom? Okay, now first of all, cannot be 1.84 cm because 1.84 cm is actually very short. Alright, something it's a length. Okay, how do I show you? Okay, let me show you 1.84 cm will be something like this. Okay, 1.84 cm. Okay, so if you look at my ruler, yeah, 1.84 cm, which is from here until somewhere here. Okay, something like that, right? So it's definitely not the height of a classroom. It's too short. And the next one is 184 cm. Now, what is 184 cm? 184 cm, if you have difficulty trying to understand that, you can change it to meter and centimeter, and that is about your height. I mean, the height of an adult. And if you look at the cupboard in your home, that is about the height of an adult, right? The cupboard is usually a little taller, right, or maybe as tall as the person. So it's about 1 meter 84 cm, right, which is answer number 2. And of course, the rest of the numbers we don't have to see because they are not possible, right? Because meters, when you have meters, they are actually very long. Okay, very long. So we don't want to use that as a measurement. It's too long for the height of a cupboard. So the answer is number 2. Okay, let's go to number 7. Now, line graph. For line graph, there is something that you need to do, right? Or 2 things you have to do. You will have to count the gaps. Okay, every time you see line graph, bar graph, you have to count the gaps. And using the gaps, which is 2 units, you have 2 units is equal to 6. Right, 18 minus 12 is equal to 6. And how do you know there are 2 units? Because there are 2 empty spaces. And 1 unit is equal to 3. Using the gaps, and you need to put the numbers onto the line graph. So your week 1 is 18, and your week 2 is 33, and your week 3 will be 36, and your week 4 will be 33, and your week 5 will be 45. So you will need to do all this first before you even answer the question. And of course, you need to read the question. The line graph shows the petrol used by Mr. Huxley over 5 weeks. So what is the question telling you? Between which 2 weeks was the increase in the petrol use the greatest? So how do you find the increase the greatest? You compare every 2 weeks. And for example, if you look carefully from the week 1 to week 2, what's the increase? The increase is you take 33 minus 18, there is an increase of 15, right? 15 liters. And then you look at week 2 to week 3, there's an increase of 3 liters. And then week 3 to week 4, there's a decrease, so we don't want to look at that. And then from week 4 to week 5, there is an increase of 12 liters, right? And then you compare which is the greatest increase. The greatest increase must be week 1 to week 2. Because why? Because the increase is the biggest, which is 15. Right, 15. So answer will be number 1, week 1 and week 2. Okay, let's go on to the next one. Question number 8. Alright, question number 8. There was a 40% decrease. Okay, 40% decrease in the petrol use in week 6 compared to week 5. So every time there is a percentage involved, there's a percentage in the problem, and there's a 40% decrease. It means that you're comparing two months or two things. So which one is 100%? If there's a 100%, then you can minus 40%. So when there is a decrease, you must always start with 100% first. So what is your 100%? So there was a 40% decrease in the petrol use in week 6, right? So week 6 must be 60%. Why? Because you're comparing week 6 with week 5. And week 5 must always start with, you must always have 100% first before you can minus 40% to get your 60%. Right? So this is what you need to do. So when there's an increase or there's a decrease, you will have to start with 100% and recognize which is the 100%, which is the week 5. And then from week 5, you decrease by 40% in week 6, which is now 60%. So how many liters of petrol did Huxley use in week 6? Then you go to the line graph, you look for week 5, and week 5 has how many liters? Week 5 has 45 liters. Okay, so week 5 has 45 liters, which is that 100%. And because there's no calculator, so what's the shortcut? Now the shortcut is not to always find 1%. You can jump. Alright, the shortcut is not to always find 1%, but to jump so that you can get your 60% quicker. For example, I divide by 5, I will get 9, right? So 20% is 9 liters. And then I jump to 60. Alright, how do I get 60? I just times 3. And then the other side, I also times 3. And I will get 27 liters. So how many liters of petrol did he use in week 6? Answer number 2. That's a shortcut without using calculator and without having to find 1% all the time, right? Okay, now question number 9. Okay, question number 9. And what do we have? Now in the diagram, okay, let me just check the answer for number 8. Okay, before we continue, let me just have a quick check to see that we are doing correctly. So question 8 answer is 2, yes. Okay, question 9. Now in the diagram below, the letters are drawn on the square grid. How many letters have more than one pair of parallel lines? Okay, the letters are not very clear. I think the first letter should be a letter C. Okay, I think it's a letter C. Okay, something like that. So there's only one line. If it's a letter C, there's only one pair. Okay, one pair of parallel lines. The second letter is a letter O. Okay, there's a letter O. So let me just draw out the letter nicely, and you will have more than one line. Yeah, one line here, one pair, more than one pair. So there's one pair of parallel lines, and of course there's a second pair. All right, and of course there are some more pairs. So letter O has more than one pair. All right, letter M. How about letter M? Letter M, that will be only one pair. Okay, one pair. And over here, there's only one pair, and this is actually a right angle. This is actually over here, this is actually a pair of perpendicular lines. Alright, it's a right angle, so when you see a right angle, the two lines are perpendicular to each other. So letter M has only one pair. And the last letter is a letter E, and that will be more than one pair. So you have one pair, and of course you can have a second pair over here. So you have at least 2 pairs, right? 2 pairs. So how many letters have more than one pair? So answer will be 2, right? Your letter O and your letter E, right? So these 2 letters have more than one pair. Okay, next one. All right. So question 10. The ratio of the red balloons to the blue balloons Mr. Abdul had was 2:3. He sold 1/5 of the red balloons and 2/3 of the blue balloons. What is the ratio of the red to the blue balloons left? Okay, so what's the method here? Is there a method that we can use to solve this? Well, you can use ratio or you can draw a model, right? So you have a few ways of doing. So let's draw the model. Now, the number of red balloons to blue balloons was 2:3. So if I can, I will always try to draw the model. Unless I can't draw, then I will have to use other methods. He sold 1/5 of the red, so which means that I need to cut the red balloons into 5 boxes, which is a bit hard. If you look at the model, there are 2 boxes of red, so it's a bit hard to cut it into 5 boxes. So what do? I can redraw again and cut it into 5 boxes, and he sold 1 box. Okay, so maybe that little box is okay, it's a bit small. Okay, that little box is sold. And then over here, this must be the left. Okay, the left. Alright. And then he sold 2/3 of the blue balloons. So over here, this is the sold, and this is the left. Alright. So your model is done already. So what do you do with the model? You have to cut them to make them all look the same, or make them all look equal. So how do you cut them? You look at the red balloons. There are 5 boxes, and also there are 2 boxes, but they are all referring to the same color. So which means that I can do something like this. Alright, cut it into 10 units, and then inside here I cut every box into 2 units, and now you can see there are 10 units on top. There are also 10 units below. So that's how you cut them equally. And of course, you have to do the same for the boxes with the same size. You also have to cut it into 5 units for the blue balloons. And then now you can find the ratio of the red balloons left. So how many red balloons are left? Which is where is it? Left. So which is 2, 4, 6, 8. Okay, so there are 8 units of balloons left to the blue balloons left, which is 5. Right? So 8:5. So your answer will be number 3. So what's the method here? Is to draw a model. Alright, model. If you can draw the model, that'll be useful, right? Because it really helps a lot to cut down the thinking. You can also convert to ratio, changing the fraction to ratio. Right? You can also do that. But otherwise, I think model will be easier. Okay, let's go to the next one. Okay, next one. Question 11, the 2-mark question. The solid is made of 11 unit cubes. So which of the following shows the front and top view? So the front view, there is a quick way to get your answer. You look at the front view, there are 2 crosses or 2 faces, and then 2 faces and 1. So you have 2, 2, 1. Okay, 2, 2, 1. Then you look at your 1, 2, 3, 4. Right? Is there a 2, 2, 1? 2, 2, 1. Yeah, there's a 2, 2, 1. See over here. Okay, there's a 2, 2, 1. Right? What is 2, 2, 1? 2, 2, 1, according to the front view that you saw just now. And then how about your top view? Your top view, you have 1, 2, 3, 4. And by the way, top view, you must always stand in front first. Always face the front, and you look down, and you will see four circles. And then 3, 4, 3 circles and 1. So you have 4, 3, 1. Okay, 4, 3, 1. Then you go to your answer options. Do you see 4, 3, 1? Yeah. 4, 3, and 1. So your answer is number 4. So that's how you draw the front view, top view, or the side view. Okay, let's go to the next one. Okay, Max drew a total of 19 dots at equal distance apart along the 3 sides of an isosceles triangle. So what is isosceles? 2 sides of the triangle are equal, and the figure shows part of the drawing. The length of one equal side is 15 cm. So what is the length of the longer side? So if this is 15 cm, then this side is also 15 cm. And you're supposed to find the length of the longer side. So immediately, even without looking at the question or reading the question, just a glance at the picture, I know that it's a method that I need to use. There's a method I need to use, which is gaps and interval. All right, gaps and interval. So what is that? You look at the dots. All right, the dots. You can see there are 6 dots, but they are not called gaps. The gaps are the empty spaces in between the dots, which is, we call them units. So the units are actually called your gaps. So there are 5 units or 5 empty spaces, which is also the distance. So the gaps also refer to your distance. And so one gap, how big is one gap? So your one gap will be 3 centimeter. And of course the other side, this side is also the same, right? So you should also have 6 dots, 3, 4, 5, and 6. So you also got 6 dots, right? And of course there are also 5 gaps on the other side. Okay, there is a total of 19 dots. So how many dots on the longer side? You take 19 dots and you minus, how many dots do you see? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you minus 11 dots, there will be 8 dots left. And where are the 8 dots which are found on the longer side? So you start to draw your 8 dots. 2, 3, 4, 5, 6, 7, and 8. So there are 8 dots on the longer side, excluding the corners. So the corners are the points, okay, the points. Okay, so these are called corners. So on the longer side, how many gaps are there? So you have 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So there are 9 gaps along the longer side. So if there are 9 gaps, what do you call them? 9 units. And 9 units will be 9 times 3, 27 cm. So the longer side is 27 cm. So immediately, when you see a picture like that, you don't have to think hard what method to use. Gaps and intervals, alright, which is a method that you will have to learn also. Okay, let's go on to the next one. Question 13. The table shows the quiz or the scores. Okay, the scores of a class of students who took part in a mathematics quiz. The 5 students who scored the highest, they form a team to represent the class for competition. So what was the average score for this team? So you have to look for the 5 students who scored the highest. So where are they? They are those who score the highest. They are those who are in the range where you have more points. All right. For example, you look at the 5 students. They must be over here, right? And how do you know that? Because they must be the students who score very high points, 8, 9, and 10 points. Okay, so how do you find the average score for this team? So to find the average score for this team, you will need to find the total score. So how do you find the total score? Then you will need to take look at the 2 students. 2 students score 8 points each. So you have 2 times 8, 16. And then 2 students score 9 points each. So 2 times 9, 18. And the last student score 10 points each. So you plus 10. So you add them together to get the total score. And you will get 44, right? I think it's 44. And how many students are there altogether? There is a total of 5 students, right? So to get the average, you must always take the total score and then go and divide by how many students, which is 5. And there's no calculator, so you will need to know how to divide to get decimal answer. So you divide by 5, so you have 8 times 5 is 40, and there's a remainder 4. And some students, they don't know how to continue from here because they forgot how to get their decimal. So change the whole number into a decimal, 0.0. Raise up the decimal point, pull the 0 down, and then you get 8 times 5 is 40, and remainder 0. So what is the average score for this team? The average score for this team will be 8.8. So answer number 2. Right? So question 13, answer 2. Okay, let's go to number 14. Okay, number 14. The figure is made of 2 triangles, ABC and DBE, where AC is equal to BC. Now, when you do angle problem, you don't work out the steps immediately. You need to do some things. For example, you need to indicate what is this. AC is equal to BC, which means that AC is equal to BC. Mark out the sides. You have to mark out the sides because it will help you to identify those triangles that are isosceles. And DE is equal to BE, which is where DE is equal to BE. So I will use 2 lines. So if there's one pair of equal side, you have 1 line. If there's a second pair of equal side, then I will use 2 lines. Okay, so and then what do I do next? I put a question mark. Find angle EBC, which is here. So this is what you must do first before you even try to work out the answer. So then what do you do next? You don't look for the answer, but you look for easy angle. Is there any easy angles I can find? I take 180 minus 70, I get 110 degrees. Easy angle, right? And there is an isosceles triangle. So which means that if this is 70, then this angle here is also 70. And I can find this angle here because sum of angles in the triangle is 180 minus 70 minus 70. So this angle here will be 40, right? Okay. And then what else can I find? And then there is a bigger isosceles triangle that you can see. So if this is 80, then I can find this angle and also this angle. So I take 180 minus 80, I get 100. And then 100 divide by 2, I get 50. And then here also 50. So that will tell me how to get the question mark, which is 70 minus 50. And the question mark is 20. So for angle EBC, what's the angle? The angle is 20 degrees. Alright, so that's how you solve angle problem. You mark out the sides that are equal, you indicate the question mark, and you put the information, indicate on the picture what are the information. And then after that, you look for easy angles, and then through the easy angles, you get the question mark. You will be able to find the question mark. Okay, let's go to question 15. Now, there were 80 members in the running club at first. So immediately, I can see that it's like a before and after problem because there's an at first. So there's a before. 30% of them were girls. Some girls left the club in the end. So there is an after, right? After is an after scenario. So you have before and after. So in the end, the number of girls remaining was 20% of the members in the club. So how many girls left the running club? So when you recognize this problem as a before and after question, then you need to ask an important question. What is unchanged? So you have some girls who left the club. So did the boys leave the club? There are no boys who left the club. So the boys is unchanged. So method to use, you have a model or you can use a table. So I will prefer a table method because it's something that can be done easily and also faster. Sometimes model drawing is effective, but sometimes you do have other methods they are better than model drawing because you can get the answer faster and it's more effective. Like for example, if you look at this table, before change after, that is your before and after, and then you label. So you have the girls, the boys, and the total, right? And then what do? You fill in the boxes, right? You look at the first sentence, there were 80 members at first. Oops. Okay, there were 80 members at first, which is an important value. 30% were girls, so you just put 30%. There must be 100%, alright, 100% altogether, right? Because 100% is the total at first. So 100% for everybody, and the boys must be 70%. And some girls left the club, so there's a minus, and we don't know how many. And the girls remaining was 20% of the remaining members in the club. So which means that the total in the end is also another 100%. So 100% is a special number that means that it refers to the total. Whether it's at first or whether in the end, it is still 100%. But it represents different total, right? Different totals. So the boys in the end will be 80%. So how many girls left the club? Question mark. And your table is done. So that's how simple the method can be, right? It is even sometimes I feel that it's even better than model drawing because you don't really have to spend time to draw the model. Just have a table and then just plug the numbers and put inside. All right. So what is unchanged? The boys is unchanged, right? Okay. So what is the purpose of this table? How do we use the table to work out the steps? Now, when you have this table, you should be looking for what? You should be looking for something in the same box. Like for example over here, right? They are in the same box. So what does it tell you? It tells you that it tells you what? It tells you that your 100% is the same as 80. Okay. And of course, do I need to find 1%? You can jump, right? Jump. You divide by 10. So 80 divided by 10, you get 8. So that I can find 30%. 30% will be 10 times 3, 8 times 3. So there are 24 girls. And how many boys? 80 minus 24, I will get 56 boys. Okay? So these are the important values. And once I know the important values, I don't have to worry about the percentage. I can actually ignore them. Okay, and then what is unchanged? The boys is unchanged. So you put the boys in the end. In the end is the same number of boys, which means that you have same box again, right? Same box. So your 80% is 56. So can I find 20%? How many girls, which is how many girls in the end? So again, I don't have to find 1%, you jump, right? There's a shortcut called jumping, right? Jumping. So you divide by 4. 80 divided by 4 is 20, and then 56 divided by 4, you get 14. So you have 14 girls in the end, right? And then now, can you find how many girls left the club? So 24 minus 14, so you must have 10 girls who left the club. So the answer is number 3. Okay? So that's how you use the table method, which is actually very effective, right? And methods doesn't help. Methods helps you not to think so much, and it will also guide you on what to do next. That's why it's important to focus on methods and to understand your methods so that you can do faster, and then it becomes easier to solve. Okay, let's go to your question 16. Now, what is the sum of all the factors of 15? This is a P4 question, so you will need to take something times something equal 15, right? And you always start with 1, right? You always start with the 1, and then 2. Can 2 times something equal 15? Cannot. Then 3 times 5, and then 4. Cannot. 5 times 3 have already. So you don't have to repeat the factors. So what is the sum of all the factors? Which means that you have to add up all the factors like this. Alright, add the factors. So 1 plus 3. Okay, again, there's a shortcut here. Some of you like to take 1 plus 3, 4, 4 plus 5, 9, 9 plus 15, and then get the answer. So a faster way of adding many numbers is to pair them up. So yeah, 1 plus 3 is 4, 5 plus 15 is 20, okay, 20. So you have 4, and then there's a 20, and then 20 plus 4, that's how you get 24. And that's how you do faster when you pair them up. Okay, complete the figure below so that the line PQ is the line of symmetry. Okay, I think the question is, I think this is a drawing that was given to us, and you're supposed to draw the other side. Okay, so how do you draw the other side? There is a lesson here. So you mark out the corners. Okay, in P4, the students will have learned how to do this. So you mark out the corners where two lines meet together. Right, two lines meet together like this. Alright, and if the line touch the line of symmetry, that's also a corner. Okay, so then you start from these dots, and then you go here. So how do you draw the next dots on the other side? You can see that from the line of symmetry to this dot is half a triangle. So you go the other side, which is also half a triangle. So you have to draw on the opposite side, which is equal distance apart, by counting the squares, or even cutting the square into half, which is half a square. Okay, then from here, go to the next dot, and how many squares from the line of symmetry? Is 1 square, alright, diagonally from the line of symmetry. So which means that over here, you have to mark out the dots, and you draw, and then from this dot, you trace the line until the line of symmetry, and you do the same on the other side, right? Okay, then from here to the next dot, how do you draw on the opposite side? You can see it cuts through 2 squares until we touch the line of symmetry. So on the other side, make sure that you also have 2 squares opposite. And then from here, okay, then from this dot, you trace all the way down. Okay, and then from here, follow to the next dot, which is on the line of symmetry, and then you connect to complete the drawing. So how to draw this symmetric figure? You have to first of all indicate the dots at the corners, at the points where two lines meet, and then you have to trace the squares to find how many squares. Alright, how many squares on the other side? Right? You have to count the squares. to find the distance, right, in order to draw the dots on the other side so that you can connect. Alright, so if you don't understand this part of the lesson, you need to play back the video, right? Play back the video to hear what I said just now. Alright, otherwise it's quite easy, right? Quite easy to draw the symmetric figure. Okay, let's go to question 18. Now, at a shopping mall, Mrs. D spent an average of $100 each week for 3 weeks. So immediately, once I know that there is an average given, and I know how many weeks are there, I can find the total. You take 100 times 3, so the total will be $300. So the table shows the money she spent in the first 2 weeks. So can I find the question mark? Yes, of course. I just add this first 2 weeks and I will get $76. And then I take 300 minus 76. And of course, what do I get? Okay, I'm going to use my calculator so we can do faster. And I don't have a calculator with me. So I guess I have to do some working, which is what you have to do. So you borrow land and 10 minus 6 is 4, 2, 2, right? So the question mark is $224, and answer is correct. Okay, so when there's an average given to you, then you can find the total. And how do you find the total? You take the average, multiply by how many weeks are given. Okay, the next one, ratio. Bala and Keith have some cards in the ratio 5:7. But Keith has 28 cards more than Bala. How many cards does Bala have? Important lesson here, even though it's a simple problem. If you are going to use ratio, then it's important that you not only put the ratio down, you also have a total there. Because many times, students are stuck, alright, they are stuck when they don't have this total and they don't know what to do next, right? Even though in this question, we don't need to use a total, but there are questions where this total is important. So I will encourage you to always put the total there. Whether it's necessary or not, always put the total there. So you have 5:7:12, and these are called units, right? So Keith has 28 more than Bala. So of course that will be 2 units more. And 2 units more is 28. So your 1 unit will be 14. So how many cards does Bala have? Bala has 5 units, and that's how you get 14 times 5, which is 70. Okay, so have a total in your ratio. But when do we put total? When do we not put total? Well, usually when the question asks for total altogether, then I will put a total there. But if the question never asks for total or how many altogether, then usually I will not have the total. So you may want to follow this guideline. Okay, maybe some of you say that, well, is it necessary to put total all the time? My answer will be it depends on the question. Like in this question, there's no total being asked, right? We are not asked to find the total altogether, so you actually don't need to have this. Yeah, but there are some questions where you need to find the total, or it's not even mentioned, alright, not even mentioned. But then without the total, you can't work out the steps. So my advice is, if you are not sure whether to put total or not to put down, then my advice is to put the total there, right? To have a total in your ratio. Okay. Okay, now next one, question 20. How do you arrange from heaviest to lightest? So you cannot compare until you make them all the same type. So how do I want to make them the same type? I can change them into all whole numbers. Like for example, 6 kilogram is 6,305 grams. Change it all into whole numbers. And how about the fraction here? Shortcut. I just have to multiply by 200 to make the denominator 1,000, because 1 kilogram is 1,000. So you just change the denominator into 1,000, and you will get 6, right? You will get 6 and 600 over 1,000 kilogram, which is how many grams? Which is 6,600 grams. Okay, that's how you change the fraction into grams. And then the 6.35 kilogram, you have to multiply by 1,000, because 1 kilogram is 1,000, so you have to shift the decimal point to the right. 1, 2, 3 times, because there are 3 zeros in 1,000. And put a 0 in the blank space and the decimal point above the arrowhead, and then the 0. So 6350.0 or 6350 grams. So that's how you compare. You have to make them all the same type, and then you look which is the smallest number. The smallest number is 6 kilogram and 305 grams. So you have to make sure that you are writing the original answer. Okay, write down the original answer, not the working answer. And then getting bigger, which is your 6.35 kilogram. And then the biggest will be the fraction, 6 and 3/5 kilogram. And that's how you compare the fractions. That's how you compare the numbers. All right. From the heaviest to the, is it from the heaviest? Heaviest to the lightest, right? Let me see. Heaviest to the lightest. From the heaviest to the lightest, I think I'm okay, mine is from the smallest to the heaviest. Okay, now, so I arranged in a different way. So let me just erase everything and okay, this is what a common mistake that I make. And some students, they also do that. They misread. Okay, misread. So what's the heaviest? The heaviest is your 6 and 3/5 kilogram. Okay, that's the heaviest already. And then getting lighter now, that will be 6.35 kilogram. And the lightest will be your 6 kilogram and 305 grams. Right, so from heaviest to the lightest. Okay, let's go on to the next one, the 2-mark question. Now, the table shows the postage rate of sending parcels to Malaysia. How much will it cost to send a parcel of 650 grams to Malaysia? Okay, what's the method? There is a method again for this kind of question, which is under rates. The method is to have a line. Okay, to have a line, and you want to send a parcel which is 650 grams, so you have a big arrow to show how heavy is the parcel. And then there are some categories here. So which category do you look at? So is it 100 grams, 250 or 500? You look for the one that is closest to the actual mass, which is 650 grams. So you look at the 500 grams, which is the closest, and you cut out the first 500 grams. So which means that you don't need to, okay, you don't have to look at these two categories. All right, you can ignore them. So how much is the 500 grams? And then you put your put your steps in your line. Right, this is a method. Right, the line is the method where you break up into first 500, and then what is the leftover? The leftover is the 150 grams. And then here, and then what do you do with the 150 grams? You cut it into every additional 100 grams. So I can cut here. So this is my 100 grams, and there's a part thereof which is less than 100. So how much is that? So yeah, $1.10, and the 50 grams is also the same. Something like your part thereof. What is part thereof? It means every 100 grams or less or lesser. Okay, then how much is the parcel? You plus them together. So you have $5.20, and I'll advise you, all right, my advice is not to do mental sums when you have to add or minus decimal. So it's best to do your working so that you don't make any mistakes. So you have $7.40, which is the cost of the parcel. And is that correct? And yep, that's correct. Okay. All right, question 22, next one. The bar graph shows the number of lanterns made by 5 children. Okay, this is a good question because there are no numbers there. We are so used to having numbers. But when you don't see any numbers, then what do? You can look out for units. Okay, units. Like for example, this is 1 unit, 2, and 3. So when there are no numbers, then you can do this, right? Make units out of the bars. 1 unit, 1 unit, 1 unit, and then this will be 5 units. Okay, and the graph was drawn based on the data and how many lanterns did the 5 children make all together. Then you look at Annie. Annie got 5 units, right? Annie got 5 units. So your 1 unit must be how many? So if Annie got 5 units, then your 1 unit must be 9. And then Emma must have how many? Emma must have 9 times 3, then 9 times 4 for Debbie, which and then Chris will be 9, and then Ben will be 9 times 2, and of course Annie is 45. So you plus them together, right? Add them all together. Okay, so let me just put down Ben. Ben is 18, and then Chris will be 9, and then you find the total that the 5 children have all together. Alright, so what do we do? That's a lot of numbers. So 45 plus 8 plus 9 is 17, then 36, and 27. So you add them all together. So 5 plus 7 is 12. 12 plus 6, 18. 18 plus 7 is 25. And then 2 plus 4, 6, 7, 10, 12. Right? So they will have made all together, is it 125? Let's try again. Is there a mistake? Oh, there's a mistake. 18 plus 9. 18 plus 9 is 27. Right? 18 plus 9. Okay, so let's try again. So 5 plus 7, 12. 12 plus 6, 18. 18 plus 7. 18 plus 7 is 25. 2 plus 4, 6. Plus 2, 8. 8 plus 3, 11. 11 plus 2, 13. So it's actually 13. So the total is 135 lanterns. Alright. Okay, question 23. Now, the figure ABC is an equilateral triangle. So when you have equilateral triangle, what you need to do is mark out the sides that are equal, and there's a line. There's a line that you see which is actually supposed to be a straight line. So the drawing is a bit slanted. So the ratio of AXC to AXB is 4:5. What do? You need to put it into your picture. Like, where is AXC? AXC is over here. And that is your 4 units. So you need to do this. And your AXB is where? Over here, which is 5 units. So when you put into your picture, what happened? It becomes clearer, and you will be able to know what's the next step. Because the next step is 9 units. Add together is 9 units, which is angle on a straight line. Right? Okay, and of course, don't forget to put down the question mark. Find your BAX, question mark. And then you solve. Right? And how do you solve? Look for easy angles. So if 9 units is 180, then 1 unit must be 20. And then 4 units must be 20 times 4. And then 5 units will be 20 times 5. Okay, and put it into your diagram. Alright, all these numbers put into your diagram. And don't forget the equilateral triangle. So you have a 60, right? Equilateral triangle means the angles inside, they are all 60 degrees. 60, 60, and here also 60. Okay, if that is 60, then what else can we do? Is there anything else we can find? Yeah, we can find, because there is a triangle that you can see, and this is 100, and there's a 60 already. So this angle must be how many? 180 minus 100 minus 60. So the question mark must be 20 degrees. So answer is 20 degrees. Okay, so lesson here is to mark out the sides that are equal, and then put the ratio into the figure, into the diagram, and then look for easy angles, and then sooner or later you will be able to get the question mark. Okay, question 24. Again, when I see a question like this, a picture like this, what's the method here? Gaps and interval. It's like your gaps and interval. So if you look at container A, where are the gaps? The gaps are the empty spaces. Okay, the gaps. So this is the gaps. Okay, for example, 0, right? You don't count from here. That is 0. Okay, and this is your one line, first line, second, third, fourth, fifth line. 6, 7, 8, 9, 10. So there are 10 lines. 10 lines. 10 lines also mean there are 10 units or empty spaces, right? The spaces are between the lines. Okay, and how big is 10 units? So if this is 0.5 liters, what do? I convert to ml. So 0.5 liters, change it into ml, and to change that, you have to multiply by 1000. Why do you multiply by 1000? Because 1 liter is 1000 ml. And how do you shift the decimal point? So to shift the decimal point, you will have to, okay, let me just write nicely, right? Okay, so how do you shift the decimal point? Let me just take out the liters, and let me just write 0.5 again, and shift 1, 2, 3. Okay, that's how you shift the decimal point to the right 3 times. And why do you shift 3 times to the right? Because it's a times. When you multiply 1000, you shift to the right. The numbers are getting bigger, that's why you shift to the right. And why 3 times? Because there are 3 zeros. So there are 2 empty baskets, you put zeros inside, and the arrowhead has a decimal point and a 0 behind. So how does it look like? 500.0 or 500 ml. So what is one gap? One gap will be 500 divided by 10, that will be 50 ml. And you start counting, right? Start counting. So how do you start counting? So you have 0. Is it? Let me see. Is it correct? Okay, let me just have a quick check to make sure that everything is correct. So you have 10 gaps is 500 ml. So one gap is 50 ml. Okay, so let's start counting and see whether how much water is in container A. So you have 50, 100, 150, 200, 250, 300, and 350, right? 350. So how much water inside this container? 350 ml. All right, how about the next one? Now the next one, you do the same. Okay, do the same. Don't count from here because there's 0. That's a starting point. And you start counting 1, 2, 3, 4, 5. So there'll be 5 gaps, which is how much? How much is your 5 gaps? So your 5 gaps is 100. Okay, 5 gaps is 100 ml. So your one gap will be 20, right? 20. And then you can start counting. So this is 0, 20, 40, 60, right? 60. So how much water is in container B? 60 ml. Yep, correct. And then the next container will be how many gaps? 0, right? The starting line is always 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 gaps again. So if there are 10 gaps again, that is 200 ml. So your one gap will be 200 divided by 10, 20 ml. And you start counting, right? So I can even work backwards. Okay, I can work backwards. 200, you minus 20, 180, 160, 140. So you work backwards, you get 140 ml. And then you plus them all together. All right, so you plus them all together, what do you get? Okay, so let's add them up. So you have 3, 5, 0, 1, 4, 0, and 60. So you add them together, 0 and 15, carry 1. So you have 550 ml. So your 550 ml, you have to change it to liters, right? And how do you change it to liters? You will have to divide by 1000. All right, from ml to liters, small unit to big units, you have to divide. And how to divide? Change the whole number into a decimal, and then shift the decimal point to the left. 1, 2, and 3. And now the arrowhead has a decimal point on top. Right, every time there's an arrowhead, you see arrowhead, you put the decimal point on top and the 0 in front. So how many liters is that? 0.550 or 0.55 liters. Okay, so what's the lesson here? The lesson here is to count the gaps. To be able to count the gaps to find how much water inside the container. Okay, let's quickly go to the next one. Now, Sarah bent a piece of wire into 2 identical quarter circles, and the radius of each quarter circle is 7 cm. Find the length of the wire, and your answer is in terms of pi. So are you finding area or are you finding circumference? You are talking about a wire. The wire is the dark lines, the dark black lines. So you need to find the circumference. And is there a shortcut to do this? Yeah. If you see something identical, you can combine them to make into a semicircle. Right? 2 identical quadrants, combine them, become a semicircle, and you can do faster. So half times pi d. And what's the diameter? Quadrant doesn't have diameter. Quadrant has radius. So you take the radius, you just have to times 2. So quadrant doesn't have diameter. When you see quadrant, you always see radius, right? So how to get the diameter? Take the radius times 2 to get the diameter. And then you will get divide by 2, 7 pi. And you highlight the sites that you have found. So the quadrants, the 2 quadrants has a circumference of 7 pi. And then how many straight lines? There are 2, 3, and 4. So there are 4 straight lines. That will be 7 times 4. That will give you 28 cm. So what's the length of the wire? So the length of the wire must be 7 pi plus 28. And then bracket cm. Okay, that's the length of the wire in terms of pi. Okay, let's go to the next one. Question number 26. Timothy is 3 years old. His brother is 4 years older. Find their total age 2 years ago. Watch out for the 2 years ago. It means that you have to work backwards. You have to minus to get 2 years ago. So, and your answer must be in terms of P. So Timothy is P years old, right? So what you can do is Timothy is P, alright? You may want to draw a model, or you may want to do something like this. Okay, Timothy is P years old, and then the brother is 4 years older, so P plus 4. So what's their total age now? Their total age now will be P plus P. That will be 2P plus 4. Alright, that's their total age now. And if you want to find their total age 2 years ago, what must you do? Many students, or some students, they just minus 2 years. Okay, but they forgot that they are 2%. So you have to minus 2 years for Timothy. You also have to minus 2 years for the brother. So you actually have to minus another 2 more years, right? Because they are 2%. So what will be your total age 2 years ago? So 2P plus 4. 4 minus 2 is 2. 2 minus 2 is nothing. So their total age 2 years ago is 2P. Okay, so take note. So if you want to find their total age how many years ago or how many years later, you will have to minus how many times according to how many person are there. So if there are 3%, then you have to minus 2, minus 2, and minus 2. Right? If there are 2%, then you just minus 2 and minus 2. Right? If there's only 1%, you just minus 2. Okay, that is the lesson here. Okay, let's go to the question 27. Wait, we're coming to the end of the paper 1 soon. Now, question 27, a group of children was asked to choose their favorite animal. Equal number of children like rabbits and hamsters. Okay, that's why I can see there are 2 rectangles, they are the same height. And the children who like hamster is twice the children who like parrots. So which means the hamster is two times and the parrot is 1 time. And the rest of the children like dogs and cats. Okay, so what do we do? Now, we can actually put something onto the bar graph. Like, what do you mean? Okay, equal number of children like rabbits and hamsters. So which means that animal B and animal D, alright, animal B, animal D could be rabbits or hamsters. Okay, could be rabbits or, okay, let me just write the word. Okay, let me just spell the word because otherwise you have too many letters and then you get confused by all the letters that you see. So, rabbits or hamsters. Agree? Because equal number of children they like rabbits and hamsters. So you have the animal B, right? Animal B could be a rabbit or could be hamsters. So we are not sure. And of course the rest, okay, the rest of all this, okay, the rest of all the animals here must be what? Must be the dogs and cats, right? Is it dogs and cats? Okay, let me see. Now, the children who like hamsters is twice the number who like parrots. So where are the parrots? Okay, the parrots must be, if you think logically, right? The parrots must be where? Must be animal C. So this must be parrots. Because why? Because the children who like hamsters, which is either animal B or animal D, the rectangle that you see, I look at the rectangle that you see over here, right? Animal B, which could be hamsters or could be rabbits, we are not sure. This one also could be a hamster, could be rabbits, and the rectangle is twice. The height is twice, right? It's twice the height of this rectangle, which is parrots, right? Parrots. So parrots must be animal C. And the rest of the children likes dogs and cats. So this one, so animal A, animal E could be dogs and cats. Am I correct? Okay, so this is what you can do on the bar graph. And then using that, you can solve. So if you look at the statement, most of the children like dogs. So where are the dogs? Do we know? Animal A could be dogs. Animal E could be dogs. So we are not sure. So the answer is what? Not possible to tell. So that's why you should put a tick over here. Not possible to tell. 50% of the children like rabbits and hamsters. Oh, is that true? So you can actually count the boxes which are like units. So you have 1 unit, 2 unit, 3 unit, and more than 4 units. So animal B is more than 4 units. And then look at animal D. 1, 2, 3, again more than 4 units, right? Okay, so if those children who like rabbits and hamsters are 50%, right, then the other 50% must be the same number of units. So if you think carefully, Do you think your animal A, C, and E is also about more than 8 units? Okay, so let's find out. So you look at animal A, right? Animal A, how many units? 1, 2, 3, 4, and 5. So animal A got 5 units. And then animal C, that will be 2 more units. So 5 plus 2 is 7 units already. And then 8, 9, and 10. So you can see that animal A, animal C, animal E is more than 50% already. Why? Because you have more than 8 units. Right? So those children who like dogs and those children who like rabbits and hamsters, right, is definitely less than 50%. Why less than 50%? Because you have animal A, animal C, animal E, which is more than what? More than those children who like rabbits and hamsters. You understand? Right? Okay, you compare the units. A, C, and E have more than, how many units are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. About at least more than 10 units. But those who like rabbits and hamsters, how many are there? There are 8 units, all right? About 8 units. So not 50%. Because when you see the word 50%, it tells you the equal number. I have 50%, you also got 50%, so must be equal number. But in this bar graph, you don't see equal number of units. So the answer is false, right? So actually, what should be the correct statements? Less than 50% of the children like rabbits and hamsters, and not 50%. So the answer is false. Okay, let's go to question 28. Okay, in the figure below, ABCD is a rectangle, find BEF. So you will need to mark out the question mark over here. And then don't care about the question mark, look for easy angle. What do you know about rectangles? There are right angles at the corners, and this angle will be 50. And then this angle here will be 40. Alright? And how do you get 40? Sum of angles in a triangle, minus 90, minus 50, and you get 40. Is there any other thing that we can find? Yeah, we can find here. This is a right angle, 90, because rectangles have right angles at the corners. And here is also a right angle, and we can find this angle, which is 90 minus 27. You will get 63 degrees. And can we find the question mark? Yes, we can, because there is a property which is sum of angles in a four-sided figure. Alright, sum of angles in a four-sided figure add together is 360. And you minus 90, minus 63, and minus 130, and you get the question mark, which is your BEF. Right? Okay, so let's work out. Okay, so let's work out and see what do we get. So I'm going to use my calculator this time, so we can do a bit faster. So 360 minus 90 minus 63 minus 130, 77 degrees. So the question mark is 77. Yep. Is it 77? And the answer key is correct. Yep. Okay, that's how you get the question mark. Okay, question 29. Azhar has some money. He donated 1/3 of it to charity and divided the remainder equally among his 5 children. So what fraction of his money did each child receive? Now it can be hard, it can be easy. If you draw a model. If you draw a model, because there's a fraction there, it can be easy. So this is the sum of money, cut it into 3 boxes, right? Because the fraction is talking about his money. And you cut the rectangle into 3 boxes, and he donated 1 box to charity. And where's the remainder? The remainder is the 2 boxes on the right side. And what did he do with the remainder? He divided the remainder equally among 5 children. So cut into 5 boxes. And so what is the fraction of the money that one child received? So what do you do next? You make the boxes all look the same, or you cut all the boxes equally, like this. 5 units, 5 units. And then the smaller boxes, 2 units inside. And then you count the units. You will see the remainder has 10 units on top and 10 units below. And you do the same for everything, right? So now you have all units already. So what fraction of the money, which is how many units altogether, which is 15 units, did one child receive? So one child, which is over here, Alright, these are the 5 children. Am I correct? 5 children. So every child gets 2 units. So the fraction is 2 out of 15. So each child receives 2 over 15 of the money. So it can be easy, right? It can be very easy if you draw the model. Otherwise, you find that it can be very hard. Okay, question 30. Last question. Now, 5 friends rented 3 bicycles from 8 a.m. to 11:30 p.m. and took turns to ride on them. At any time, 3 of them rode on the bicycle, while the other 2 friends rested. Each of them had the same amount of riding time, and that is like average, right? Average means everybody all the same. How many minutes did one person ride on the bicycle? Okay, now this can be a hard question, and what's the method that we can do over here is to draw a diagram. Okay, draw a diagram and do some listing. Alright, why do listing? Because you don't have a lot of friends. I mean, you don't have a lot of people in this problem. There are only 5 friends, and there are 3 bicycles. So not a lot, not a big number. So what I can do is, I can draw 3 rectangles to show 3 bicycles. Okay, 3 bicycles. So the method I'm using here is to draw a diagram. Okay, and how does it work? There are 5 friends. So you have the first person, second, and the third person riding on each bicycle. And you have the 4th and the 5th person resting. Okay, so there's a bit of listing over here. And then the first person rests, come out, right? And then you have second, third, 4th, and the first and the second person resting. Alright, so you're doing something like listing. And then you have the third, 4th, 5th, and the first 2, and then you have the, is it correct? Let me see. Second, third, 4th, 5th. Okay, let me adjust a little bit. Some transfer error. So you have second, third, 4th. This should be 5th and 1, and then third person, 4th person, 5th person riding bicycle, and first and second resting. And then you have 4th, 5th, and 1. Alright, so these are the people who are riding, and then the second and the third person resting. And then you have the 5th person, and then you have the first, second, and third, and the 4th resting. Okay, so you can see that everybody all has equal number of turns. How do you know everybody all has equal number of turns? You look at all the rectangles. You can see 5 person riding on each bicycle, right? So everybody all has equal number of turns. So they rented 3 bicycles from 8 a.m. to 11:30 a.m., which is how many hours and minutes? So you have to find the duration, which is 3 hours and 30 minutes. And then you will need to change this into minutes so that you can divide. Otherwise, you can't divide. So 3 hours is 60 times 3, 180 minutes. 180 plus 30 will be 210 minutes. So which means that they rented the bicycle for how long? They rented the bicycle for 210 minutes. Am I correct? Okay, and then what do you do next? Okay, so what do you do? Okay, then you look at the picture. Okay, look at the picture, and there are 5 person, right? There are 5 person. So you take the total time they rent, and because there are 5 person, so each person will ride how many times? Each person. So you have to divide by 5. Okay, divide by 5 because there are 5 person, right? So divide by 5 to get 1 person ride how many times? So 210 divided by 5, you will find that each person will ride 42 minutes at any one time. So when the person when a person ride on a bicycle, how long does it take to ride the bicycle? Which is 42 minutes for one time. And then you look at the diagram. Each person ride how many times on the bicycle? So you look at the first person. The first person rode 3 times. And then how about the second person? The second person will also have rode 3 times. So everybody will have ridden or will have rode 3 times, right? So each person will have sat on the bicycle 3 times. So which means that how long did everybody ride on the bicycle? So you take 42 minutes and you times 3. Because each time on the bicycle is 42 minutes. And if everybody rode on the bicycle 3 times, then what is the total minutes that each person ride on the bicycle? So you take 42 times 3 and you will get 126 minutes. So which means that each person must have rode on the bicycle for 126 minutes. And then how about the rest of the time? The rest of the time you will be resting. Okay, resting. Alright, so that's how we do question 30. Alright, and we are done. Okay, we are done with the paper 1. So hopefully by the end of the lesson now, you have a better understanding of the concepts that you have learned. And if you have forgotten the concepts, I think it's a good chance for you to revise now and to remember, refresh what you have learned. Okay, so we come to the end of this paper 1 lesson. So stay tuned for the next online lesson, next lesson video. We will continue to look at some other school papers, and then hopefully through all these paper 1 lesson, you would have a you will score well, right? You score well for your paper 1, right? Okay, so see you in the next lesson.